Physics, always sweet. I welcome everyone to watch this session. Today we are going to discuss about concave mirror versus convex mirror. What is this? You are wearing specs? We are standing in front of children to discuss something. What? We are going to discuss about light chapter. Specs related with light. That's why I am wearing. Okay. If I remove, you will feel better. Then okay. Already we know about plane mirror and spherical mirror. In the spherical mirror, there are two types, concave mirror and convex mirror. Concave mirror, really it is beautiful and it has so many uses. Convex mirror also beautiful, so many uses. Concave mirror plays a vital role in our life. Convex mirror also plays vital role in our life. Okay, you decide after watching this which one is beautiful and which one plays a vital role in our life. Concave mirror. Before watching this, we should know the interesting history of mirror. Do you know which one is first mirror in our earth? Water? Yes, water was the first mirror for our ancient people. People started to look at their reflections in pools of water and river. Even I know the history of after that. Stones, polished stones were mirrored 6000 years ago. These kind of mirrors have been found in one country. The country name is Turkey. Later in Egypt, people were used metals and alloys as a mirror. Afterwards only, this type of mirror, glass mirror, we are using this in our everyday life. It is invented in Germany 200 years ago. It is just a glass. If we coat paint or silver at backside of this glass, it will become mirror. Good finishing about mirror history. Now come to our discussion, concave mirror. Wow, sweet and healthy watermelon. It looks like round shape. Shall we go for lower class mathematics? If we draw a line from the center to edge of the circle or sphere, it is called radius. And if we cut one side, it is a part of a sphere. It looks like curve or curvature. Now imagine this is a glass ball and this one is a part of this glass ball. Where is the center of this ball? It is here. Where is the center of this curvature? That is also the same location. Why? Because this curvature belongs to this ball only. So this location is the center point for this ball and this curvature. Hereafter, I am going to use only this curvature, not remaining part. Why? Because concave mirror and convex mirror looks like this piece only. Now this piece not exactly looks like concave mirror and convex mirror. So I am going to shape it properly. Now we got the shape what we needed. Curved inwards, curved outwards. Now if we paint this side, then this side will become a reflecting surface. Now it is called convex mirror. In case If we paint this side, now this side will become a reflecting surface. Now it is called concave mirror. Now you tell me, where is the center for this curvature? If we extend this curvature, we will get a sphere. Yes, this is the center for this curvature. Center of curvature denoted by symbol C. This is the first term. The middle point on the surface, it is called pole. The symbol denoted by P. This is the second term. The distance between pole and center of curvature, it is called radius of curvature. It is denoted by symbol capital R. This is the third term. So this is the radius of curvature. The midpoint of this radius of curvature, it is called focus. It is denoted by symbol capital F. This is the fourth term. Next, distance between pole and capital F. This is called focal length. It is denoted by symbol small f. This is the fifth term. Next, pole, focus, center of curvature, all these points located in one line. This line is called principal axis. This is the sixth term. The last term, it is nothing but size of the mirror, otherwise height of the mirror. It is called aperture. So this is the last term, seventh term. So there are 7 terms. We have learnt basic terms. Shall we draw ray diagram? It is very easy. Don't be panic. Take your pencil, scale and notebook. We should know 4 light rules to draw ray diagram. Rule number 1. If the light travels parallel to the principal axis, then it will be reflected through F. This is the rule number 1. Next, rule number 2. If the light passes through C, then it will reflect through C. Rule number 3. If the light passes through F, then reflected ray parallel to principal axis. Rule number 4. If the light ray strikes on the mirror point P, then the reflected ray follows the law of reflection. It means I is equal to R. Before entering ray diagram, we should remember the terms what we have learnt. Mn is the concave mirror. P is the pole. Capital F is the focus. Capital C is the center of curvature. A, B is the object. A dash, B dash represents image of the object. This black color line representing incident ray. In some other sheets I have used brown color. This red color line representing reflected ray. Generally, how the concave mirror works. If the light ray strikes on the surface of concave mirror, it will converge. It means after reflection, concentrate at one point. Due to this, concave mirror has another name, converging mirror. If we place an object in front of concave mirror, what type of images will get? That is depend on position of the object. It is not like our plane mirror. In front of plane mirror, wherever we stand, we get the same image with same size. In this concave mirror, there are 6 positions for the object to be placed in front of concave mirror. The first position at infinity. If we place an object at infinity, we will get the image at focus. How? From the 4 rule, we may take any 2 rule, but for this position, 1 rule is enough. Light rays from the object travels parallel to the principal axis. Then it will reflect through focus. Already we have studied this rule. Now reflected rays meets at one point. At which point it meets, at that point we will get image. So we will get the image at focus. For this position we get real and inverted image only. The second position beyond C. When we place the object beyond C, we will get the image between C and F. How? From the 4 rule, we may take any 2 rule. According to rule number 1, if the light rays from the object travels parallel to the principal axis, then it will reflect through focus. Another rule, if the light ray passes through C, then it will reflect through C itself. Now these two reflected rays meets between C and F. So we will get the image between C and F. For this position, we will get real and inverted image. Third position at C. When we place the object at C, then we will get the image at C only. How? From the 4 rule, we may take any 2 rule. According to rule 1, if the light rays from the object travels parallel to the principal axis, then it will reflect through focus. Another rule, if the light ray passes through F, then it will reflect parallel to the principal axis. Now these two reflected rays meets at C, then we will get the image at C only. For this position, we will get real and inverted image. Fourth position between C and F. When we place the object between C and F, then we will get the image beyond C. How? From the 4 rule, we may take any 2 rule. According to rule 1, if the light rays from the object travels parallel to the principal axis, it will reflected through focus only. Another rule, if the light ray passes through C, then it will reflect through C itself. These two reflected rays meets at beyond C only. So we will get the image beyond C. AB is object, A dash, B dash is the image of the object. For this position also, we will get real and inverted image. Fifth position at F. When we place the object at F, then we will get the image at infinity. How? From the 4 rule, we may take any 2 rule. According to rule number 1, if the light rays from the object travels parallel to the principal axis, then it will reflect through F. Another rule, if the light ray passes through C, then it will reflect through C itself. Now these two reflected rays meet at infinity only. So for this position, we will get the real and inverted image at infinity. Sixth position, yes, the last position between P and F. When we place the object between P and F, we will get the image behind the mirror. How? From the 4 rule, we may take any 2 rule. If the light rays from the object passes through C, then it will reflect through C itself. Another rule, if the light ray strikes on pole P, then it will reflect with the same angle P. It means reflected ray follows laws of reflection. I is equal to R. After reflection, these rays appears to come from a point behind the mirror as a divergent rays. In fact, the ray of light not coming from the point it appears. Due to this, we will get image behind the mirror. For this position, we get visual and erect image. A dash B dash is the image. Now come to convex mirror. Generally, how the convex mirror works. If the light ray strikes on the surface of convex mirror, it will diverge. So it has another name, diverging mirror. After reflection, it never meets at one point, but we will get the image. How? When we extend these reflected rays, it appears to meet at one point at the back of the mirror. So we get the image, visual and erect image. Now we will learn ray diagram for convex mirror. In convex mirror, there are only two positions. The first position at infinity. If we place an object at infinity, we will get the image behind the mirror. How? From the 4 rule, we may take any 2 rule. But for this position, 1 rule is enough. According to rule 1, if the light ray from the object travels parallel to the principal axis, then it will reflect through focus. Actually, if we extend these reflected divergent rays, it will appear from focus. So we will get the image at focus behind the mirror. For this position, we get visual and erect image. Now the second position, yes, the last position between infinity to pole. If you place an object between infinity to pole at any place, we will get the image behind the mirror only. How? From the 4 rule, we may take any 2 rule. According to rule 1, if the light rays travels parallel to the principal axis, it will reflect through focus. Another rule, if light ray passes through C, then it will reflect through C itself. Actually, if we extend these divergent rays, it will meet behind the mirror. Behind the mirror. For this position, also we get visual and erect image only. Now you tell us which is best, concave or convex? I think concave. No, convex mirror. Open your mouth and tell us convex mirror. Yes, the conclusion is both mirrors are best because both mirrors plays a vital role in our life. Yes, both mirrors.